Now, the frequency polygon has been constructed using a histogram in the previous session. Now, we will try to construct a frequency polygon without the help of a histogram. That is, we're going to directly construct the frequency polygon without constructing the histogram and then taking the mid of each of the width of the rectangular bars as obtained in histogram. So let's see how a frequency polygon can be constructed without using its respective histogram. So this is the class interval. So let's take an example problem where I have the class interval of all ages ranging from 0 to 10, 10 to 20, 20 to 30, then 30 to 40, 40 to 50, 50 to 60, and 60 to 70. Then I have the number of patients who are ranging between 0 to 10. There are no patients who are there in the age group of 0 to 10. Then I have 5 patients who are in the age group of 10 to 20, then 9 patients between 20 and 30, and 16 patients whose age is between 30 and 40, etc., with no patients also between 60 and 70 years old. So with this problem, let's see how a frequency polygon can be constructed, but provided the histogram is not constructed for that particular frequency polygon. So as usual, we know that when we just graph, we need an x and a y axis, but before that, the only additional part of what we're going to find in case of constructing without drawing a histogram. So the only additional column in case of drawing of a frequency polygon without the help of a histogram is we directly take the class mark or the mid values into consideration here. So when I have the class interval from 0 to 10, the mid values, which are also called as class marks, are taken into consideration. As we know that the mid value between 0 and 5 can be comfortably taken as 0 plus 10 by 2, which is 5. Therefore, in this case, I take the mid value as 5. Similarly, when I go to the class range or the age group of 10 to 20, then 10 plus 20, which is 30, divided by 2 is 15. So my mid value can be comfortably taken here as 15. Similarly, going with this, I can get the mid value here as 25, 35, 45, 55, and 65 is how I obtain the mid values for each of the respective class intervals or the ages. Now for this, we are going to form the points which are taken into consideration without the help of histogram. Now it is at this column where we directly get the points which have to be joined using a ruler for forming a perfect frequency polygon or an n-sided closed figure. So let's see how the points are obtained from the given this thing. So I take the mid values or the class marks on x-axis and I take the number of patients on y-axis. Then for each of the class marks or mid values and each of the number of patients in the respective class mark, I form the points because x-axis has all the mid values of class marks and y-axis has number of patients. So I'll form an x and y coordinate using these and these of the column. So in case of this, 5, 0 forms the first point which has to be plotted, and this will be the first vertex of the frequency polygon. Then next, I'm going to join 5 and 15 and 5, which will form the second vertex. So I frame the coordinates with this and this, with this being the x coordinate of the point and this being the y coordinate of the point. Then in this case, I get 25, 9, which forms another point related to the class interval 20 to 30. Then similarly, I have 35 to 16, 16 as one of the point. And here next is 45, 11 and 65, 0. So when I have each of the points, I'm going to just plot them on the xy coordinate system and join them with a ruler. I get an n-sided closed figure called the frequency polygon without constructing its respective histogram. So let's see how the points are plotted on an xy coordinate system. So going with this, let me take the graph which is x-axis and y-axis and the origin. As we all know that x-axis is always plotted with the class interval. So but because the class interval is indirectly related with the class marks, I take all the mid values or class marks on x-axis, and then the y-axis has the frequency. Now this being the frequency, the number of patients will be the frequency for this given problem, hence will be plotted on y-axis. So I get this is how the class marks and the number of patients are plotted respectively on x and y axis accordingly. Now, in order to plot these points on the x and y axis, initially it's very important to make the suitable scale for x axis and y axis for this particular problem. So let's see what is the least x coordinate and what is the highest x coordinate is clearly understood with 5 and 65. So I take in a range of 10, 20, 30, 40, 50, 60 and 70 as with the scale of 1 centimeter equal to 10 units on x-axis. So comfortably my scale on x-axis is 1 centimeter equal to 10 units. Then proceeding with the similar manner, and for y coordinates, my lowest y coordinate is 0 and my highest y coordinate is 16. So I can take in as with 1 centimeter equal to 2 units, where I can take 2, 4, 6, 8, 10, 12, 14, 16, etc. So here on y axis I take 1 centimeter equal to 2 units. So using these two scalings for x and y axis separately, then let me just plot. So here I have 10, 20, 30, 40, 50, 60, 70, etc. on x-axis, and then 2, 4, 6, 8, 10, 12, 14, 16, 18, etc. on y-axis. Now next, to proceed with plotting of the points, I take the first point, which is 5, 0 and identify where it lies, as I clearly see that it lies between 0 and 10. So 5, 0 is a point which lies out here. So this is the initial coordinate which lies out here. The next point, which is 15, 5, is going to be plotted somewhere here. This is my second coordinate which I'm going to plot. Then my third coordinate is 25, 9, so approximately this is 25. Now proceeding with the next point, which is 35, 16. So I have 35, which is the x coordinate between exactly 30 and 40, and 16, which is plotted on the y-axis shooting somewhere here. So this is how I get one of the point related to 35 and 16. So what about 45 and 11? 45 and 11 would have exactly 1 unit above 10. So I take exactly somewhere here where 11 lies between 10 and 12. So I have it between, I can take it as the mid value. This is 9 and this is 5, exactly between. And then I have 55 and 3, which exactly lies in between. And then I get the last point, which is 65 and 0 would obviously be there on x-axis, just like the first point, which is also on x-axis. Now I got the set of points which are plotted on the xy coordinate system, and these points, when joined continuously using a ruler, will form a frequency polygon. That's it. We don't have to construct the histogram, but directly we can construct the frequency polygon by just plotting those points and then joining them with a ruler. So let's see how we can do it exactly straight. 1, 2, 3, 4, 5, 6, 7. This is a 7-sided polygon, which is a septagon. A frequency polygon here is a septagon because this is the frequency polygon which has been obtained from the given class interval or the given frequency distribution table. Now we have constructed a frequency polygon which has been shown through the shaded region. So this is the frequency polygon, in this case being a frequency polygon which is a 7-sided polygon. This is a seven-sided polygon, or it is also called a septagon. So the frequency polygon as obtained for this particular data or the given frequency distribution table is a septagon, which can be identified in case of this. So now let's see how a frequency curve is drawn for the given data. So I have considered the same data as in case of the previous example, because a frequency curve is nothing but a frequency polygon joining with a free hand. Now when I wanted to plot the points, it is as similar as plotting the points in case of a frequency curve, but once I plot the points in case of a frequency polygon, I just join the points using a ruler, but in case of a frequency curve, I join the points using a free hand. A free hand joining of the points will give me a frequency curve. The joining of the points through a ruler will give me a perfect frequency polygon. So this is how I differentiate between a frequency polygon and a frequency curve. Joining with a free hand is what is the core of this topic. So let's plot the points as in case of the previous example, similarly with the same rule of scale of x-axis taken as 1 centimeter equal to 10 units, and with y-axis scale as 1 centimeter equal to 2 units. Then finally I get x and y-axis, so that this is x-axis and this is y-axis and this is origin, and from here I take the points 10, 20, 30, 40, 50, 60, 70, 2, 4, 6, 8, 10, 12, 14, 16 and 18, and here I take all ages because the class interval is about ages, so the subject of x-axis should be ages. Of course ages are taken in years, so I also mention the units. Usually x-axis has to mark the labeling of x-axis, or y-axis has to be with the situation what is taken into consideration along with its units. Now age is in years, and here comes number of patients. So here comes number of patients, and here comes ages in years. And as in case of a frequency polygon, the way we have plotted the points is what similarly we're going to plot with the same points on xy coordinate system. So let's plot the points initially. So phi 0 is a point which is taken on x-axis here. So this is the point phi 0. The next comes 15, 5, which is plotted on 15, 5, which comes here. So this is the second point. Then the third point is 25, 9. So 25 and 9, which comes between like this and this. Then I have 35, 16. So 35 is plotted with 16. The next comes 45 and 11, which is nothing but 45 and 11 with 55 with 3. So my x coordinate is 55 and my y coordinate is 3, which lies between 2 and 4. So therefore I get 55 and 3. Then finally 65 and 0, which comes somewhere here. So this is how I get the points, where in case of construction of a frequency polygon, I just join each of the points with a straight ruler so that I get a frequency polygon or an n-sided closed figure. But in case of a frequency curve, I do not use the ruler, but I just join the points with a free hand, a smooth continuous curve using a free hand. So therefore, when I start with this point, this is how I join with a free point. So now I got a frequency curve, not a frequency polygon. So this region will give me the area under the curve, and this line is called frequency curve, which I obtain by plotting class marks on x-axis and frequency on y-axis. So this is how the frequency curve is obtained. The core of understanding frequency curve is by joining the points through a free hand, a smooth continuous curve through a free hand. So we have already discussed about less than cumulative frequency and greater than cumulative frequency, and we also constructed a cumulative frequency distribution table. And coming to those topics as a recap, so let's see how a cumulative frequency curve or initially starting with how a less than cumulative frequency curve can be constructed using the given frequency distribution table. So similarly, you can also construct a greater than cumulative frequency where the whole of the graph depends on the least or the greatest cumulative frequency. So initially, I'm going to start with a less than cumulative frequency curve for an example data which I have considered here. So in case of this data, we can see that the class interval is the number of days, that is 0 to 4, 4 to 8, 8 to 12, 12 to 16 and 16 to 20. Now for the number of tenders is nothing but 2, 5, 12, 10, 3, which is nothing but the frequency. So here is the class interval and here is the frequency. So this is the frequency distribution table which I have considered as an example problem. Now for this example problem, I'll be constructing a less than cumulative frequency curve. But before this, I understand this problem in real life as, so I have 2 tenders from 0 to 4 days. I have 5 tenders who have been working from 4 to 8 days. I have 12 tenders who are working from 8 to 12 days and 10 tenders working from 12 to 16 days and 3 tenders working from 16 to 20 days is what I understand in real life. Now coming to this, let's see what are the essential factors for constructing a less than cumulative frequency curve. So for a given class interval and a frequency, the first and foremost thing which I require for the construction of the respective curve is the upper bound. Then I need the least cumulative frequency, which we already have done in the previous sessions. So we all know how to construct the less than cumulative frequency column for the given frequency. And then we consider the points as x coordinate and y coordinate respectively, and then we plot the points and we get a frequency polygon. We get a less than cumulative frequency curve by joining the plotted points through a continuous smooth curve from a free hand, joining by a free hand, not to use a ruler. So coming with upper bound, let's see what an upper bound in case of this class interval is. As we all know that the class interval ranging from 0 to 4, all the initial values or the lower bounds, so 0, 4, 8, 12, 16 on the left are the lower bounds respectively for each of the class interval, and 4, 8, 12, 16, 20 are the upper bounds for each of the class interval. So when I take the class interval 0 to 4, 0 is the lower bound and 4 is the upper bound. Therefore, because I demand for upper bound in this column, so I take the upper bound here, which is nothing but 4. So for the first row of the range ranging from 0 to 4, my upper bound is 4. For the next class interval ranging from 4 to 8, my upper bound is 8. And for the next class interval ranging from 8 to 12, my upper bound is 12. And in this case, my upper bound is 16. And then finally, the upper bound here is 20. So one thing in mind, that when I construct a less than cumulative frequency curve, I need an upper bound. Assuming that for constructing a greater than cumulative frequency curve, I need a lower bound, which we're going to see in the next session. So for a less than cumulative frequency curve, I need an upper bound is what I recollect or remind when I do the problems. So with this upper bound, how do I construct a less than cumulative frequency from the given frequency? As you've already seen that this is the frequency table given out here. So in this case, the lower cumulative frequency or the less than cumulative frequency is constructed from top to bottom, and upper cumulative frequency is constructed from bottom to top by recollecting what we already done this. So 2, and then I go from 2 plus 5, which is 7, and then 7 plus 12. I add the respective penultimates with the given existing frequency. So 7 plus 12 is 19, and 19 plus 10 is 29. 29 plus 9 is 32. So this is how I get each of the frequency values for the less than cumulative frequency as constructed through stepwise from top to bottom. So once I obtain the less than cumulative frequency, then comes on how I plot the points. So where do I plot the points? So here the upper bound and the less than cumulative frequency are taken on as x and y coordinate in plotting of points. So I have my points which I have with x coordinate as 4 and my y coordinate as 2, because class interval is taken along x axis and the frequencies or the respective less than cumulative frequencies taken on y axis. Hence this value corresponds to the y coordinate and this value corresponds to the x coordinate. Similarly, when I go to the next class interval 4 to 8, my respective point would be 8, 7, and then coming to the next, I have 12, 19, followed with the next point which comes as 16 and 29, and then followed with finally 20, 32. So these are the 5 points which I'm going to plot on XY coordinate system and then join them with a freehand, and thus I obtain a cumulative less than cumulative frequency curve for the given problem. So let's take the XY coordinate system with the suitable scale. So I take x-axis, y-axis, origin, and when it comes to the values on x-axis, it is nothing but number of days. The subject is number of days, which comes on x-axis, and the number of tenders, which comes on y-axis. So this is how the class interval and frequency are followed as the rule on x-axis and y-axis respectively. Now with this, the point 4, 2, 8, 7, 12, 19, 16, 29 and 20, 32 had to be plotted with a suitable scale. Therefore, I start with x coordinate. So the least of the x coordinate is 4 and the highest is 20. Therefore, I take a suitable scale of 2, 4, 6, 8 or 4, 8, 12, 16, 20. So in this case, I get 8, 12, 16, 20, 24. And then coming to this, also I take the suitable scale of 4, 8, 12, 16, 20, 24, 28, 32 and etc. with 36. So here on x-axis, my scaling is on x-axis, it is 1 centimeter is equal to 4 units, and even on y-axis, it is the same scale. 1 centimeter is equally 4 units even on y-axis. So with this suitable scale, let's see how the points are plotted on this x and y-axis. So for the plotting, let me start with the first point, which is 4, 2. So 4, 2 will clearly be a point which lies here. Then coming to the next point, which is 8, 7. So approximately it is 8, and then coming to this, 7 would be somewhere out here. So this is the point followed for the second class interval. The next is 12, 19, which comes with 12 and 19, followed with the class interval out here. Then 16, 29, which comes with 16 here and 28, and on the top is 29. Then finally it is 20, 32, which comes with 20 here and 32 on to the top. So I have got totally 5 points plotted on the x and y axis coordinate system. So to obtain the less than cumulative frequency curve, it is nothing but joining of the points from first to the last through a continuous freehand, a continuous smooth curve joining by a freehand. So let's start with this. So when I just randomly join continuously with a smooth freehand, this is how I obtain the less than cumulative frequency curve. Of course, this is only the sketching of the graph I have done, but when you graph it on a graph paper with accurate measurements, you get a perfect graph. This graph which I have drawn is not a perfect graph because here the exact dimensions are not taken. Randomly, the values are taken on assumption. So to get a perfect graph, doing it on the graph paper would give an accurate and more perfect graph. So this is the less than cumulative frequency curve. Less than cumulative frequency curve joined by point number 1, 2, 3, 4 and 5. So So as we have identified the less than cumulative frequency curve here, there's one important geometrical concept which we identify here. That being that less than cumulative frequency curve is always increasing. As you can see, when you start with the first point, the graph increases continuously. So less than cumulative frequency graph always increases. Less than cumulative frequency curve is an increasing curve. And the greater than cumulative frequency curve would be a decreasing curve. So this is how we justify the less than and greater than cumulative frequency curves.